Let's try to resolve this initial velocity 9.5 meters per second at an angle of 40 degrees with the horizontal. So we denote this as the initial velocity, which can also be denoted as V sub O. O stands for origin, I stands for initial. They are the same notation, so whichever you are comfortable with, go with that. So how to resolve this into a horizontal VOX and vertical VOY? You need to apply your knowledge of trigonometry. So just like in math, we do this. For example, on the horizontal axis, so from the head of your arrow, you drop it down until it intersects your x-axis. So that's going to be how long your initial velocity along x will be. And then on the y-axis, similar method, you have to project it along the y-axis, and then from the starting point to your projection, that's going to be your VOY. And then now we have like a triangle here, which will be used for our analysis. So our hypotenuse, this serves as our hypotenuse, which is the value of 9.5. This becomes our adjacent side, which means it's close and located to the 40-degree angle, and this serves as our opposite side. So in order to find out first the VOX, the function that we use is going to be the adjacent side and the hypotenuse side, which will be a function of, in trigonometry, you use cosine. So cosine of the angle is equal to adjacent side over hypotenuse. But we do not have adjacent. We do have the VOX. And for the hypotenuse, we don't have H, but we have the VO. So the ratio of that is going to be cosine of the angle 40 degree, the one that was given to us. So to manipulate, since this is given, and we know this as well, so we can find the VOX. So by manipulating that, you're going to find that the initial will just be multiplied by your angle theta. So what I want you to understand in here is that your x, in order to get rid of that, because we do not know the value of that, it's our just notation, carries the function of cosine of theta. So if you plug in the value now, it will become 9.5 meters per second multiplied by the value of cosine, which is, if you plug it in your calculator, it's going to give you a value of 0.77. So the answer will be 7.2 meters per second, and that's going to be positive because it is on the first quadrant. So similarly, you will be able to find your VOY by using the function of sine of an angle, which is opposite over hypotenuse. But remember, we do not have again the opposite and the hypotenuse. What we have is the opposite angle, VOY, and the adjacent, the hypotenuse, which is your V initial. So by manipulating this equation, you're going to find that this, we know when we press in the calculator, this is given to be 9.5, so we can readily solve for the VOY. So if you try to isolate that on one side, VOY will be simply VO sine of 40 degrees, as given in this problem. Okay. And if you try to plug this in your calculator, you're gonna get 9.5 meters per second times the sine of 40 will give you a value of 0.64. So you carry the significant figures, two significant figures will give you 6.1 meter per second. So that's the value of your VOY.